The way you study every subject for the best results is different. The way you study English is different to how you study chemistry, which is different to how you study maths. But I hope to tackle the math side of things today, as that's an area that I feel I know better. I'm hoping to get a couple of colleagues who've done really well on the English and chemistry side who can manage those subjects. But this will be a video for the year 11 and 12 students on how you can most effectively learn and study maths to achieve the best results in the least amount of time, which will help balance all those subjects that you have in those final years of school. So, with all learning, we have to start with learning the actual concepts, then applying the material, and then working on how we manage exams and tests. So, I'll break it down into these three stages. I think one thing that I did poorly in year 11 and 12 is I learned too much from the textbook. It would just be, reading the textbook or going through the textbook, but try and use a range of different sources because this will help you learn the information more deeply. So yes, you have the textbook, but that's largely going to be reading, right? And that level of depth in the textbook isn't great for fully understanding a concept. I think getting someone to teach you is better. So to learn the concepts as well, you have the textbook, you have YouTube videos. I remember Eddie Wu was really helpful when I was trying to learn some new concepts in sort of year 10 maths. You can get AI to teach you the concepts, and then you have different types of class. Now you have your school class, but then you also have tutoring. Now, a key thing for me was I wanted to know the material before I got to class because maths class it's a really hard subject to teach because you have all these students at different ranges of skill levels. And sometimes it depends on how good your teacher is, but like they might spend a whole hour's worth of class just solving one problem that you could solve in 5 minutes. So lots of the people I know did really well in maths. Actually, like in maths class, they were just doing their own thing. They weren't even listening. So it depends on whether you think that actual teaching class is useful or useless, and whether you're better off just doing your own thing. But for me, the goal was to already have learnt the material and be confident with it before the class itself, so then I can make a decision. I think if you're trying to just learn the material in the actual class, it's very difficult because some people will know the stuff already and will find it easy, and it'll seem like everyone else is getting ahead. And if the teacher goes fast, you're in a lot of deep trouble. So I would want to have some sort of prior knowledge before class, and I'd want to know the material well. Now, with maths, the one trouble is that there's almost always a way to just get the answer via a shortcut. So here's an example. Let's say you're learning about calculus, right? And if you don't know how to do this yet, or if this is, not the type of math you're doing, that's fine. But let's say I ask you, like, what's the derivative of x squared? Okay. Now, it's really, really easy to learn the tricks. The trick is you take this number, you write it out the front, and then you decrease the power. This is this number by one. So I take the two, I write it out the front, and then keep the x, and now it goes x to the one. Done. Okay. And like, let's say you just learned that trick. That would allow you to do a bunch of different things, right? You can do the derivative of x to the 8. You can do the derivative of x to the half. You can do the derivative of x to the negative 5. It's simple. All you do is take this number, put it out the front, and then decrease the power by one. But you have no idea why you're doing that, right? So the trouble is, lots of people will just learn that trick, and that they'll get most of the questions right, but they don't know why, like where any of that comes from. Now, learning those principles, for the most part, is going to take longer, but it's those principles that will help you when you get these complicated worded questions. Every year on our maths exams, there are certain questions where less than 5% of people get the answers right. And those questions are all about the principles. They're all about ideas. And so that's why it's helpful to have someone actually teach you these background things and to actually have the curiosity to learn that. So yes, there's always going to be shortcuts, but principles first. If you learn the principles, learn them deeply, and you need to have the time for that. But that will then make the shortcuts. You'll know exactly when to use them, and you'll be able to answer the questions that test more than just the shortcuts themselves. So you know what you understand by what you can teach. And a lot of the times in maths, we just think, oh yeah, that makes sense. I can get it right. But then if I ask you to like teach this calculus to a year seven and expect the year seven to ask why at each stage. So, okay, you put the number out the front. Why? Most people can't answer that. You decrease that by one. Why? You know? And so like, what is the derivative? What is calculus? These are the questions that are reasonable follow-up questions, which if you understood the material, you would also be able to answer. So try to gauge your confidence in a concept by how well you can teach it and how well you can do, the questions. Now, it's not strict phases. It's not just I'm going to learn and then I'm going to do questions. It's often a bit of back and forth. So, okay, maybe you do a little bit of learning. You read a bit of the textbook, you watch a YouTube video, you try a few questions, and you get like three right, but then you get two wrong. So there's a bit you know, but there's a bit you don't know. The questions will tell you what you don't know. And once you have awareness of that, you need to switch back and learn that material. So it's a constant seesaw. Learn a bit, apply. Okay, I applied it, I got a few right, so I know this bit, but then there's still a bit that I don't know. And now I'm going to have to do more complicated advanced learning to get that. Eventually, you'll be able to get everything basically 100%. Now, you don't really need to take many notes in maths. I think people are over-reliant on notes. Almost any formula, number one, should just make sense to you. But number two, like if there's something that you need to memorize, I think you can just memorize it. There's not that many formulas in high school maths that you need to know. So rather than taking notes, I would just be doing some sort of flashcards or questions. Rather than me writing out the quadratic formula, x equals negative b on 2a, whatever, then I would just say like, okay, quadratic formula. And then that would be one side of the flashcard. That would make it a lot easier. And then if you forget the quadratic formula, you can just Google it. Uh, so I would rather write questions in flashcards rather than notes. And I would be trying to memorize formulas because that will, like having it in your head is a lot different when you're answering questions to having it simply written down on a page. And we want to get to a stage where you can answer the more complicated questions and you need that knowledge in your head. And that all goes back to the principles. Also ask the question, okay, where does that formula come from? Why is it negative b on 2a? Why is the discriminant when it's less than zero? Why does that mean there's no solutions? If you can answer those questions, it indicates you actually know it. Okay, then application. Do questions early. So I told you that learning and application are integrated here. You learn a bit, you apply. The application will tell you what you should learn next. So that learning occurs in chunks. If you just think you can like read the whole textbook and then just be able to answer every question in the textbook without any integration, that's when you run into trouble. Another point, the best students at maths can do things quickly. So always be thinking, how can I do things faster? What steps are necessary here? When I practice myself, I put myself under time pressure. I would try and do a whole chapter review in, 1 or 2 periods. And I just sit down, try and get as much done as possible. But the important parts, I think, are thinking, how can I do this a bit faster? But then most importantly, like anything you get wrong, you need to come up with some sort of like diagnosis and then management. So why did I get this wrong? Did I just guess this plainly, or was this just, a silly mistake? Did I accidentally say, 1 + 1 is 3? Sometimes that happens. And then why did that occur? Did that occur because there was some like bracket here that made it more likely that I make that mistake? Or was I like just lazy and I'm a bit tired? And then what are you going to do about it? It's not good enough just to say, all right, I got this wrong. I'll get it right next time. All right, how can I fix this? In one of my previous videos, anything you learn is only learnt once you put something into action. So you might have said, okay, when I was expanding my bracket, I made the mistake of just expanding it out like this. Now, in the future, I know this is a very common mistake that I make. So if I finish with any time spare, let's say I have 2 minutes to go, I'm going to look through all my working out for any cases where I'm expanding a bracket with a negative sign and just make sure I haven't made this mistake. Then it's a simple way of just catching and eliminating that mistake in the future. So any mistake you make needs some sort of action. Either you might change the way you check, you might go learn more about that concept, etc. But the mistakes are the feedback, so that's the most important bit. Now, there's a distinction between doing questions from the textbook and then doing exam style questions. Textbook questions have a very short stem and they just tell you what to do. Find the derivative of this. Do like this multiplication. They're often like shorter, one or two steps. Whereas the exam style questions, which you get in practice tests, practice exams, practice SACs, they generally have a longer stem, more steps, and they get you to think a bit more. So you can't just study for an exam doing textbook style questions. The textbook will tell you when you've learnt the material. But once you've learnt the material, get on to the exam style questions. Um, Now, I think one disservice that schools do to is they often don't give you many good resources to practice on. So that's where it's helpful to get a tutor who has resources or to, find online practice SACs, practice exams that you can use before your SACs. Because using the textbook as preparation for an exam is is not the best strategy. It's like preparing for a bike race by running. It may be somewhat helpful, but not really. Now, I find people who do lots of textbook stuff, they will get the textbook things right, but the textbook will tell you what to do. It doesn't give you the opportunity to come up with ideas, to toss out concepts. If you're practicing a particular style, it'll all the questions will be that same style. Whereas in the exam, they often don't tell you, use this particular calculus strategy or use this type of probability. So you need just practice in a variety of contexts so you can come up with ideas. And being good at the textbook stuff does not mean you're good at the exam stuff. So these steps are still necessary, but you have this learning and application phase of which the textbook is a part of. But then there's this exam strategy and exam prep phase, which will then require, the practice SACs and your exam management strategies, which we'll now talk about. So, the most underrated part of exam revision, I think, is checking. The first part of checking is having enough time to check. So that's why you should always be thinking about when you're practicing, how can I do this faster? Like realistically, let's say there was a 1 hour methods exam. When I was practicing at home, I would try and get that done in 15, 20 minutes. Now, if you can get an exam, a 60-minute exam done in 20 minutes, realistically, you have the opportunity to then check that whole exam twice over. So for me to make a mistake, I would have to, number one, stuff it up when I'm doing it the first run. Number two, miss it when I'm checking the first run. And then number three, miss it when I'm checking on the second run. So people can push yourselves to like really get lots of questions done in time. Now, there's a difference between going fast and rushing, right? So you still don't want to rush and then just make a bunch of careless mistakes. But giving yourself time to check is something that we should all strive for. And there's different ways you could do it. There's ways of checking if you had 5 minutes. And how I would do that would be just diagnosing like what are all the common mistakes, all the silly mistakes that people make. Decimal points, forgetting the domain, expanding out the bracket like I suggested earlier. Not saying like this is the part of the reals or not putting a negative sign or not putting the units. All those things you can check in 5 minutes. And then there's a longer check. Let's say, 60-minute exam, you finish in 40 minutes, you've got 20 minutes to check. How are you going to check the questions? My most important thing here is to check in a different way to how you solve the question. Lots of the times, if you've just done the question and done 4 lines of working like this, people check by just reading and be like, oh yeah, that looks good, that looks good, that looks good, that looks good. It's like when you write something out and you've written a typo, but you're just reading it and you miss the typo. Rather, try and check in some different way. Can you take the answer and sub it back in at the start to see if it works? Can you do a different line of working? And then if you still get the same answer, that works as well. The idea is, let's say on a particular checking method, you're 80% effective. And then you do a different method, and that method you're also 80% effective. Now, to get something wrong, you'd have to stuff this bit up and stuff this bit up. So now, rather than doing something that's 80% effective, you do something that's, over 90% effective. Because to get something wrong, there's a 1 in 5 chance you get it wrong here, 1 in 5 chance you get it wrong here. So there's only a 1 in 25 chance that you get it wrong overall. Okay, so that's how you go from being an 80% student to a 96% student. So checking is very important. First step is speed, but then you actually have to practice that. No one teaches you checking in schools. Um, and very people do checking on their own. Like they normally just do all the questions, mark it straight away, but there's no checking time. So checking is a skill that you have to practice. You need to learn to catch your mistakes. To do that, you need to know what the common mistakes you make are and why you make them, and then what you can do about it. Now, lots of people perform at home on practice exams, but not in the actual test environment. Now, you need to figure out if you're one of those people early. So, how have you done your 10 exams, your 11 exams? And you need to actually put some things into practice to manage that. That itself should be like a subject taught in schools. Are you going to have a particular pre-exam routine, breath work, practice exams in an actual exam setting context? Are you going to practice in the library versus at home? Are you going to practice with noises and distractions around you? To work out the time pressure for a 2 hour exam, are you going to set yourself 1 hour, 30 minutes and then practice, finishing early like that? There's many different things you can try, and for every person, it'll be different. But you need to acknowledge if you're the person who exam stress has negatively impacted in the past and do something differently about that. Now, lots of people will spend lots of time revising content when they could have been spending time on practice exams. These are not separate things. Practice exams is a way of revising content. So what I'd suggest is once you are done with the overall content, for most schools, that's, early or midterm three. So some people are done with the content at the start of the year. But whatever you get wrong in the practice exams should then give you an indication of what content you need to revise. And by revise, not reading the notes, it's okay, maybe I'll try and give a lecture on that topic, or I'll try and do some, exam style questions specifically in that area. What you should avoid doing is just say, all right, I'm now finished all the content. I'm now going to just go through every single chapter and make sure I know it. Oh yeah, okay, chapter one, I'm going to read my notes. I feel reasonably confident with that. That sounds good. All right, I've revised that. That is just a massive red flag because it's all passive. If you really want to know what content you're weak on, do 3 practice exams, categorize all your mistakes, and then the ones you make the most mistakes in, revise that topic. Revise that topic by giving a lecture to a friend, doing further practice questions, watching or getting the AI to test you, you know? So do some active way of practicing the areas that you make the most mistakes in, and then gradually funnel that out. So let's say you make the most mistakes in calculus, spend the next day focusing on calculus. Then do a few calculus only questions. Once you feel like you've got the hang of that and you've improved, then go to the next topic you're worst in. Maybe it's probability and do the same thing. So exam revision is not, oh, I'm going to focus on every single area equally and just go in order. Avoid that. What you should be doing, spend the most time and the earliest time on the topics that you make the most mistakes in. The practice exams tell you which topics those are, and then to actually revise that, you need some way of actively revising. Teach a lecture, do AI teach me via the Socratic method, do the textbook questions, do some practice exam questions. And the way you know that you've adequately learnt the topic is when you start getting questions right. Okay, so what did I do to achieve good scores, and what would I suggest people do? So in the holidays, I completed all the questions from one textbook. Then during the term, as we were learning in class, I completed all the questions from a second textbook. Before every test or actual SAC test, there's different names for it, I would write a 1 page summary of all the important things I needed to know before that test. I would complete the chapter review of the relevant chapter because that was exam style questions, and I would do practice SACs probably 1 week before the exam, the sort of particular test it was. Now, this approach took me many hours, but when you just do textbook questions all day, you get really quick. I'd always practice under some sort of intensity. And the good things are like before the SAC, there's some exam style questions, and the good thing about practice questions is they are active. They make you think. They don't give you the answers. Now, do I suggest this approach? No, because this is not the most efficient way of doing things. What I would do is yes, use the holidays to learn some of the topics, but also learn and apply at the same time. So I think it's pretty reasonable to get ahead of your schoolwork, whether that's with a tutor or by yourself, and learn and apply things based from the textbook. So you look at the textbook chapters, you might want to stay a term ahead, something like that. It doesn't have to be that long ahead, but it's up to you. Then I would learn the topics using textbook, YouTube, AI, and then do questions simultaneously and judge how well I know that based off how many of the textbook questions I'm getting right. In the class itself, I would try and say after each class, do I feel confident teaching that? Can I explain this to a friend who might ask you questions? And during the term, rather than doing another textbook, I would be spending more time on the sort of practice sacks, practice exam side of things. Uh, in the week before the sack, then I think, yes, I'm still happy to do chapter review, practice sacks, uh, try and ditch the notes and replace them with flashcards. That's what I'd suggest. So, do you have to complete every single question in the textbook? No. I think once you start like getting things right, if you can get, 5 or 10 right in a row, if you can explain it, then the teaching point is there, and you don't need to do like A to J and just mark it all. That's probably just extra time that you could have spent more efficiently. I hope I've done this justice. If you have any questions, please write in the comments or let me know. I haven't talked about the calculator much here. So briefly speaking, you just need to know the relevant functions of the calculator and you need to be confident with how to use it. Um, there's people who overuse it, people who underuse it, but take it into your own hands. Don't expect your teacher just to say, all right, these are like everything you need to know and how you need to know it. Talk to a past student, talk to your tutor, whatever that may be, and you need to like be confident explaining what the different functions are, and that's where that knowledge of the underlying principles is so helpful. Again, stay tuned. Hopefully, I'll have some more videos coming covering other subjects. But if there's anything I can help with on the math side of things, do let me know. And I hope this was a helpful video. Thanks, guys.